Energy Code Compliance for Metal Building System webinar Part 2 will provide information in detail as it pertains to the insulation prescriptive compliance options within the 2015 IECC. This webinar and other webinars in this series are brought on by the Metal Building Manufacturers Association. For more information about MBMA, go to mbma.com. I will be the host for these webinars, and my name is Jay Johnson. I'm the Director of Architectural Services for MBMA. This slide shows 4-part of the webinars that you have access to. Part 1 was designed more at a higher level introduction that provides some information of interest that needed not to be repeated within Part 2 and 3 for the IECC and ASHRAE Standard 90.1 webinars. Part 3 will get into the level of detail as you will see here in Part 2. And be sure to check out Part 4 with its gets into the trade-off method. Topics covered within this webinar will provide information on the R-value method and the U-factor method, specifically related to insulating a metal building. The primary reference document continues to be the 2015 IECC and ASHRAE Standard 90.1 2013 version, and the information contained within these webinars are included in greater detail within MBMA's Energy Design Guide 2nd edition, of which is available on mbmamanual.com, and we encourage you to obtain a copy of the IECC and 90.1, whatever version is commonly used within the municipalities that you work within, and these can be found on iccsafe.org or ashrae.org. So let's dive into some code language. I know this is not very exciting stuff, but the intent of these webinars is to get down into the details to allow you to understand how to meet the energy code provisions for a metal building. So it's not really at a higher level, but it gets down into what is actually in the code and how it relates to a metal building. So we'll review the R-value method. Some code text here. If you go to section C402 1.3, it outlines the R value based method. Basically, it focuses in on the building thermal envelope for opaque assemblies, and you're needing to meet the requirements of section 402.2, which is for the roof and the walls, and 402.4 applies to fenestration. And these are all based on the climate zone that we discussed in Part 1 of the webinars. So for the opaque portions, meaning the non-windowed or glazed area of the thermal envelope, you would need to comply with the insulation component for either on the R value basis as outlined in table 402.1.3. Again, based on where you are within the United States. 402.2.2 refers to the roof assembly. And again, it points back to the table mentioned earlier. And then for walls above grade, it also points back to that particular R value table. And I mentioned fenestration. Fenestration refers to windows, doors, and skylights. And there's their own sections within the IECC of interest. Now the U factor only has this code language. Actually, I cut off part of it that was not of interest for this particular webinar. So we'll take a look at the assembly U factor and the U factor table. But for now, let's take a look at the R value method. This is the table that you probably are the most familiar with, and most likely building officials are most familiar with. We often get questions here within MBMA, technical inquiries, either from metal building suppliers, erectors, architects, or engineers, trying to figure out if there's other options beyond the specific insulation systems outlined in this table. And I always say yes. And so that's what kind of generated the idea of putting together this webinar series. So this is the R value method table. It really is the easiest to comply with, and most people do use this table specifically for metal buildings, where it highlights metal building roofs and metal building walls above grade. But before we dive into all these insulation options for metal buildings, let's review what's all involved in this table. So I took out all the details within, and notice on the top bar there's the climate zones 1 through 8, and this simply points back to the climate zone map. So depending where you are in the country, you'll notice on the full table that the insulation levels, regardless of the type of roof or wall, would increase as you get up into the colder climate zones. Going back to the map, you'll notice here in climate zone 4 and 5, it actually separates it down further, where you have climate zone 4 here and climate zone 4 here. So 4 except marine, so anything east of this vertical line here, so you could be in climate zone 4A, shown in yellow, or 4B, shown around this area, and then the climate zone 5 or marine. So anything in climate zone 5 in green, or the marine 4 to the west of this bolded squiggly line. More information about this table is broken down. Each climate zone is broken down into 2 individual columns. Group R is simply the occupancies outlined within the IBC, International Building Code, that's designated as Group R. So anything that is commercially related that would have living or sleeping areas such as dorms, nursing homes, or even prisons. Although metal buildings can be used for any and all building applications, oftentimes we're more outside of this Group R category, and so we'll focus in on the all other column. So this includes all other occupancies other than Group R. Let's get to the left of the table. The insulation entirely above roof deck, metal buildings, and attic and other focuses in on insulation for roofs. Now, as mentioned in part 1 of the webinar series, even though you have a metal building which is defined as having purlins, C or Z shaped, spaced 5 feet on center on average, or walls with C or Z shaped girts spaced roughly 5 feet on center, you may have a different type of roof, whereas the insulation is not installed in and around the purlins for the roof. So you may have a metal building that would use open bar joists, and that would include a metal decking laid on top of the bar joist, and then you would have continuous insulation, maybe rigid board, set on top of the metal decking, and then you would have your roof membrane covering. And so that would be insulation entirely above deck. So that category could be used even though you have your typical tapered rigid frames and your common purlins and girts for the walls. However, if you kind of get out of that purlined area, you would investigate what's within the insulation entirely above deck. Then you have attic and other. That's typically your attic spaces for commercial application. And if you fall outside of these three categories, you would get into the other category. So you would need to insulate it to the higher levels. You have mass walls such as concrete tilt-up. You have metal building walls, as I already described. You have metal framed walls, which could be installed in a metal building. Metal frame refers to your steel stud walls. And then you would take a look at the insulation provisions within this table for that. And your metal building you may have areas that would fall under the metal building category and areas that would fall under the metal framed categories. You also have the wood frame, your wood studded areas, and then the other category, or the other. If you fall outside of these four designations, you would get into the other. I'm not sure how best to describe that. So basically, this row would have more insulation than these top three. You have walls below grade. You have floors or joist framing, mass floors or joist framed floors, and then your slab on grade, whether they're unheated or heated slab. And you may or may not have insulation requirements. This particular table for the IECC includes non-swinging doors. It's not related to insulation, but for some reason they included it in this table. And for non-swinging, you would have opaque doors, such as garage doors and rolling doors, and there is a particular R value associated with these doors. So we'll focus in on metal building roofs and metal building walls. I want to point out two footnotes. There's a little footnote up here at the top of the table, footnote A, and then a specific footnote for metal buildings, footnote B. Footnote A, it says for any insulation used for any building type, you would take a look at the assembly descriptions within ASHRAE 90.1 Appendix A. So even though you're using the IECC to meet the code, it points you outside of the IECC for information about these particular roof and wall and floor insulation types. And for metal buildings, for B, when you're using the R value method, when you're using the R values compliance method, a thermal spacer block shall be provided. Now, a thermal spacer block is associated with a standing seam roof, and the assembly descriptions and the table that I'll point you to here shortly shows a standing seam roof. So you are not permitted to use a through-fasten screw-down roof, even though it's not specifically clear unless you get into ASHRAE 90.1. So you need a thermal spacer block for a metal building roof. Otherwise, use the U-factor compliance method shown in Table C 402.1.4. Moving on to the next slide, let's kind of cut out the metal building roofs and go ahead and white out the rest of the information. And you'll see for climate zone 1, you would have an R19 plus R11 LS. LS refers to a liner system. So this is a cavity filled type system, and it increases in thickness, or the amount of insulation I should say, as you get up into the colder climate zones. So remember, note A pointed you to the assembly descriptions, and I went into 90.1 and extracted that information. So let's read this real quick. This assumes that the metal building roof has a base assembly with thermal spacer blocks where insulation is draped over the steel structure of the purlins. The purlins are spaced nominally 5 feet on center, and the insulation is compressed when the metal roof panels are attached to the steel structure or the purlins. It's not really good code language, and we suspect this will be revised probably within the next version of 90.1 yet to be published. But hopefully you get the gist. And the liner system, LS, is defined as shown here. So basically you have 2 layers of insulation that fills the cavity and includes an R3 thermal spacer block between the purlin and the metal roof panel, unless you use the U-factor method, which we'll get into shortly. Without reading all the code text, a liner system basically has the R11, which would be the lesser of the 2 R values compressed. You would have your R3 thermal spacer block, your standing seam roof, your purlins spaced no more than 5 feet on center if you're using the R value method. And the lower insulation would be the R19 or the R25, or it could be the R30, which would be unfaced. This lower layer would rest on a membrane or a vapor retarder, which is held up by longitudinal and transverse metal banding secured to the purlins. So this vapor retarder would cover the lower part of the purlin, so you would not see the secondary framing member. There are other cavity-filled insulation systems out there, and we'll take a look at those in part 3 of the webinar series. So in summary, climate zones 1 through 5, you have R19 plus R11 liner system. Climate zone 6, it jumps up to R25, and 7 and 8 jumps up to R30. So you'd simply use these. You would contact an insulation supplier. Typically one specializes in metal buildings to understand all this, and go from there. It's as simple as that. I added another note. Note B summarizes the R value method with thermal spacer block, which we already reviewed. And you probably know that thermal spacer blocks are commonly not used. Actually, 99% of the time not used with a through fastened roof, because you would need to have longer fasteners. And so you would need to get in touch with the metal building manufacturer up front to make sure that they are aware of this structural change, to see if they would have any other recommendations for a through fastened roof. You can use a through fastened roof if you go with the U-factor method. ASHRAE 90.1 has this table, which I often refer people to when going the U-factor method. However, we are still on the R value method. Regardless, I wanted to point out a few things within this on this page. This is one page. I just kind of broke it up for the purposes of this PowerPoint slide. So table A 2.3.3 of the 2013 edition of 90.1 has this format of a table. You have your standing seam roof with thermal spacer blocks. Of course, there's always footnotes, and this was a footnote A and B. Coming down here to the lower part, you have footnote A. This assumes a standing seam roof clip with a distance of 1.5 inches. So that's your minimum height of the standing seam roof clip. And note B refers to the R3 thermal spacer block. So R3 thermal spacer block for a standing seam roof would apply to a single layer fiberglass system, a double layer fiberglass system, and the liner system. Fiberglass systems. Moving down further on the page, there is a filled cavity type of insulation, which is not quite the same as a liner system, and so it increased the thermal spacer block size up to R5. And of course, you have the option for a standing seam roof without thermal spacer blocks. However, I'm not aware of any situation where you would use that, but there is that option there. And the U factor number is not as thermally efficient as one with a thermal spacer block. And then you get into a through fastened roof without thermal spacer blocks, of course. So getting back to the R value method, I just wanted to point out the standing seam roof with the liner system, the R19 plus R11, 25, and 30, as prescriptively outlined within the IECC table, assumes a standing seam roof with the R3. So it all lines up in how I explained earlier. Now let's move on to the R value method as relates to metal building walls. This is an excerpt out of the table C 402.1.3 for metal buildings. And notice across all climate zones you have a fiberglass plus continuous insulation system. So that's what the CI means, continuous insulation that uses insulating material that is continuous across all structural members without thermal bridges other than the fasteners and the service openings. The continuous insulation may be installed on the interior or exterior or is integral to any opaque surface of the building envelope. So this is directly out of the Energy Code. So what does this look like? Here are some drawings out of our energy design guide where it shows the fiberglass, which would be the first rated system off of the prescriptive R value table, and the second would be the continuous insulation, which could be installed on the exterior, which is, I think, more of a challenge in the field, or it can be installed on interior, whereby the continuous insulation would then need to be protected by other means, maybe by gypsum board or other types of materials. So this is your option. So for climate zones 1 through 3, you have an R13 plus R6.5 CI, which is roughly 1 inch of rigid foam board, or R13 plus R13 CI, so roughly 2 inches of foam board. Now the Energy Code does not specify or go any further into telling you what type of continuous insulation to use. So it could be rigid foam board, it could be spray foam, it could even be insulated metal panels if the thermal bridging would not be part of the system when the panels overlap. There is a note A that I referred to earlier. So you can find these systems and other systems in ASHRAE 90.1 in Appendix A, and how these are how these are assembled, and a little more descriptive text on single layer and continuous insulation. Now we'll move on shortly into the U-factor method. So if you want to move away from this type of system, which is a viable option and will likely to remain in the energy code, especially for the limits on the U-factor, and this will be the same systems that will be included in the 2016 version of 90.1. Actually, let me correct that. This will be the same systems that will be in the 2018 IECC. And then we'll get into in part 3 what will be included in 90.1 2016 version. So now let's get into U-factor. So maybe you want to move away from that combination of fiberglass plus continuous insulation, or you want to see what options are available outside of using a standing seam roof, and you may want to try to find a system that meets or is more stringent than the U-factor presented. So what are U-factors? U-factors came into play for the past 2 or 3 code cycles. Before, it was all about R values. So for U-factor is a thermal transmittance of a product assembly, I should say, not a particular product. An individual product would have a U-factor number, but we're taking a look at the assembly. And this is measured in BTUs per hour per square foot in degrees Fahrenheit. The U-factor numbers that you'll see in the prescriptive table takes a look at the framing, at the fasteners, framing spacing, the fasteners, and the insulation, whether it's compressed or allowed to fully expand between the metal building secondary framing members. So it takes a look at all the various R included. In simple, in order to get to a U-factor is basically 1 over R. To figure out the U-factor of a rigid board, since it's uninterrupted by framing, it would just be the R value, 1 over the R value. And then you would add in the air films for the interior and exterior and get to your total U-factor. But for metal buildings, we will take a look at a single layer. I try to illustrate heat loss between framing members and the major heat loss that occurs where there's metal framing such as a purlin and the insulation is compressed. The length of the arrows may not be evident to see, reduces on some of these drawings, trying to illustrate less heat loss or less thermal bridging. So even though you would probably have the same amount of heat loss between framing members, you would have a lot more at the purlin and a little less if you have a thermal spacer block with a standing seam roof versus a through-fastened roof without a thermal spacer block. Get into a double layer system, less heat loss between the framing members, and probably about the same between the second drawing and the third drawing, since this is basically the same information or components. Today's energy code fills the cavity. Obviously a lot less heat loss because this whole area is being surrounded by insulation. And so you got 2 layers, a lot going on here, so that means more thermally efficient. The lower the U-factor number, the better the performing. Taken out of ASHRAE, you have a through-fastened roof, R19, notes a U-factor of a 0.151, and you'll notice these numbers in red are reducing all the way down to 0.031. So the lower the number, the better the performing. These U factors are determined by hotbox test via the ASTM standard for hotbox testing, also done by computer modeling, and based off of validation, new calculation methods are being introduced within ASHRAE 90.1 for metal building roofs and walls. You may just want to pick an insulation system to meet a particular U factor number. It's kind of sort of out of a catalog, so to speak, or a list or a table. The most recognized, nationally recognized sources are allowed, such as ASHRAE 90.1 Appendix A for metal building roofs and metal building walls. Also, product suppliers are another great resource that can provide you with systems to meet your specific project needs that may go beyond the assumptions within the assembly descriptions within 90.1. So now let's go back to this exciting table. I switched it up. Now this is the U factor number, same format, same climate zones, same group R and all other columns. Same types over here for roof, walls, and floors, and so on. So we'll take a look at metal building roofs and metal building walls. Notice they're just all U factor numbers. So we, based off of the IECC code text, you don't even need to look at the R value table any longer. Just simply use this table. And note A and B, note A points you to ASHRAE 90.1. The use of opaque assembly U factors from 90.1 shall be permitted, provided the construction, excluding the cladding system with the appropriate construction details, aligns with Appendix A. So we'll go back to the table A 2.3.3 for the roof and Able 3.2.3 for the wall. Note B points you to ASTM C 1363. Basically what it says is you can use assembly. You can use assemblies provided by your product manufacturer as long as they tested the assembly according to this ASTM standard. So let's look at metal building roofs for the U factor. In summary, climate zone 1 through 5, climate zone 6, climate zone 7 and 8 have different U factor thresholds, and it does not require you to use a specific insulation type. You could use all continuous insulation, you could use all fiberglass, or a combination of the two. And you can also use insulated metal panels, although the tables within 90.1 does not describe insulated metal panels, so you need to get with your product supplier. I included footnotes A and B as a reminder, and so in summary, note A allows 90.1 assemblies, and note B allows suppliers. So consider using one of our MBMA building system members or MBMA associate members for product-specific options. So they would be most familiar with fiberglass, continuous insulation options, whether it be rigid board, spray foam, or insulated metal panels, and maybe other options I'm not thinking of for this slide here. So let's get into some code text. U factors for 90.1 descriptions. U factors for metal building roofs. It basically points you to the table A 2.3.2. And you could use calculation methods provided in Appendix A9. Notice it assumes that the roofs, in order to meet the U factors, The purlins are spaced at least 52 inches on center, and the insulation is compressed for the top layer between the purlins and the metal panel. The U factors for metal building walls. It points you to a separate table for metal buildings. You still have other options with Appendix A9. Now this assumes the girts are spaced at 52 inches on center. So let's take a look at this U factor table within 90.1. And let's see what options are there beyond the prescriptive R value method to meet the 0.035, 0.031, and 0.029. Option 1, you could use continuous insulation only, but that's a lot of continuous insulation. Typically about 1 inch is roughly 5 to 6.5 per inch. So that's quite a bit of continuous insulation to use on the roof, but that's an option if your project warrants it. You do have the option to go with a fiberglass plus continuous insulation, and this may be useful for retrofit application. Older energy codes just uses a single layer or 2 layers of fiberglass compressed over the purlins. For whatever reason you have a change of occupancy, now you need to bring it up to the energy code. You have the option to include continuous insulation. So say if you have an R19 over the purlin fiberglass system and you have a specific level to meet, let's say in climate zone 7 for the 0.029, what this table tells you is you have R19, or in and of itself equals a 0.082, which is not very thermally efficient. This accounts for the thermal bridging at the compressed fiberglass insulation. If you add continuous insulation with an R value of 22.1, combination of these two will give you a 0.029. So in essence, you have these options here depending on what system you have, whether it's brand new construction or retrofit applications, whether it's standing seam roof or a through fasten roof. Now you'll notice for the same system, the R19 for a through fasten roof without thermal spacer blocks, of course. For the R22.1, you have a U factor of a 0.035, which is a lot higher than the 0.029. So that would not work if you're trying to meet climate zone 7. So you would need to up the ante around an R30 to R32. Second option, since it's hard to meet a fiberglass only system for a roof, is just simply revert back to the R value method and go with the systems already defined. You can switch it up, go with the R value method for the roof and maybe use the U factor method for the wall. So that is still an option. Speaking of walls, let's see what options we have for the walls if we want to move away from the fiberglass plus continuous insulation for these particular U factors. The lower climate zones has a 0.079. The upper climate zones a 0.052. Still that footnote A and B. I won't repeat all this. In this table, it just goes down to R19. You have single layer fiberglass. These are the U factors, and no other options are below this. You have the option to go with continuous insulation only to get closer to these U factor numbers, such as R19 or R13, continuous insulation, so that would be none, no fiberglass, just all continuous. However, the latest edition of 2016, 90.1, includes more options. You still have the single layer up to R19, but it adds more metal building wall options. What I did, or what ASHRAE did, I should say, is incorporate this approved addendum CP, which can be used in conjunction with 2013 90.1 all by itself. But you are allowed to use the latest version, even though the 2015 IECC specifically references to 2013 90.1. Sorry for all these years and number references. My point is, you are allowed to use the most current version of 90.1 for this particular table, because they always give you more options. So what Addendum CP did was provide a single layer in cavity, so R25 and R30, and 2 layers of insulation for the wall. Also, there was a second addendum shown here, DZ, which just provided some editorial changes within Addendum CP, and it reorganized this table that provides you with a clear understanding that continuous insulation only is an option, and then it breaks it down with the fiberglass systems. Single layer in cavity has a note A and B. So note A, you would have a very thin strip of a thermal spacer block or a thermal break strip tape to meet the R value of 0.375, and then note B would have 0.075 for a thermal spacer block for that system. These 2-layer systems, only one of them includes or requires an R3 in order to meet this U factor of 0.039. You'll notice the R25 plus R10 without the thermal spacer block has a 0.047. With the thermal spacer block, 0.039. So the options to meet this U factor, again, point back to continuous insulation option only. So that's a good option. Or for fiberglass only, the only other option beyond fiberglass plus continuous insulation would be this new single layer in cavity R30, which gets you to exactly 0.052 for climate zones 4 through 8 within the 2015 IECC for the U factor method. So let's take a look at these new insulation descriptions for metal building walls. You have the single layer in cavity and then the double layer metal building wall. In the past, this term was used in the older versions of 90.1 where it had 2 layers compressed between the wall panel and the girt. And that was removed, at least from the prescriptive tables, since that's not commonly used. And this new definition for a double layer system has 1 layer compressed and 1 layer uncompressed. So going back to the top, you have a single layer and it introduced the word compress. So this is a single layer compressed between the girt and the metal panel. You have continuous insulation with an editorial change there with the word of. Single layer in cavity, as kind of described in this drawing here, fills the cavity without compressing any insulation, any fiberglass insulation between the girt and the wall panel. Remember, there was a footnote, so there is a small little sliver of a thermal spacer block. I believe it's 0.375 from memory. If you use that table, product suppliers may have insulation assembly U factors without a thermal spacer block. And as far as for this single layer in cavity, this typically metal building insulation has a facer included. You do have the option to have it separated, so the membrane is either installed separately or adhered to the insulation. Getting into the double layer, the first rated R value shown is the insulation installed in the cavity, so higher of the two numbers. The second rated R value of the insulation is compressed. And you may or may not have a thermal spacer block or a brake strip tape. And the vapor retarder may be adhered or separated and installed as one sheet that would cover the girt, as opposed to exposing it. So since I showed you the 2016 table for walls, this is what it looks like for the roof. So we're back to table A 2.3.3. No major changes, just different color formatting. The only change, there was an approved addendum A-B, and that introduced a new filled cavity system. We'll review what a filled cavity system in part 3 of the webinar series. I'd like to summarize the past 4 code cycles, and you could take a look at this in detail. If you'll notice, back in 2006, it was all about R values, and there was no U factor. U factors were introduced in 2009, and it's slowly increased in stringency. You'll notice the U factor numbers and the R value levels increasing. We pretty much have met or maxed out on how much insulation that can be included within a metal building. So you'll notice no changes in the 2012 and 15 IECC, and that should be the case in the 2018 Energy Code. And this is what it looks like for the walls. So part 3, we'll get into 90.1, and I want to briefly show you how to navigate to there from within the IECC. Chapter 4 of the IECC has the general scoping provisions, and this is basically, or has the same information in the other versions, older versions of the IECC, just with less and less text as you get into the older versions. But in essence, the IECC gives you the options. First, says commercial buildings shall comply with one of the following. It first points you to ASHRAE 90.1, and it basically is telling you to move outside of IECC, which is odd since you would think you would want to encourage the provisions within the IECC. But to simplify it, it provides you the way to use 90.1, and it does reference a particular year based on the version of the IECC. So this would refer to the 2013 90.1. So use 90.1 or the various provisions within the Energy Code. And so this would point you to the 13 edition. So we'll get into greater detail to using 90.1 in part 3 of the webinar series. If you have any questions along the way on a particular project, or any questions that I did not get into deep enough within this webinar series, feel free to contact us by going to mbma.com, utilizing the Contact Us form, and we will help you out as much as we can.